Capacitors are electrical components that stores electrical energy. They are different from batteries because battery stores electrical energy using chemical reaction. But in the case of capacitors, capacitors store electrical energy using two parallel plates very close to each other with a dielectric material between the two plates. Also, the rate at which battery charge and discharge is very slow, but in the case of capacitor charges and discharge very fast. In an atom, there exists the nucleus, which is at the center of the atom. Inside the nucleus, it contains the neutron and the protons. The protons are positively charged. Outside the nucleus are the electrons. The electrons are negatively charged and they are free to move because they have lesser weight. In an atom of a conductor, electrons are free to move about. So if you connect a battery, the battery is like a pressure, an electrical pressure that move the electron from one point to another in a particular direction. But if battery is not connected, the electron will move randomly, and this is useless. You can't just pop or push an electron into a metal plate because there are a lot of electrons inside the metal plate and there is no space for another electron. So what we can do is to bribe them with a positive charge. As you know that positive charges, opposite charge attracts and the same charges repel. If you put a plate that is positively charged very close to a negatively charged plate, they will attract. If we have two metal plates that are very close to each other and make sure they are not touching, we've created a capacitor. Capacitors are measured in capacitance. So the material that is in between the two metal plates is called the dielectric material, and it also determines the capacitance of a capacitor. The dielectric material can be any material that is not conducting electricity. It can be air, paper, or anything that is an insulator. The permittivity of a material used as a dielectric material is also important. They use different materials to make a capacitor. For example, electrolytic capacitor, ceramic, mica, and so on. And the used material determine maybe it will be polarized or not. For example, tantalum and electrolytic capacitor are polarized. So the electrical symbol for capacitors is like this. Capacitance is equals to permittivity of free space multiplied by the permittivity of used material multiplied by the area of the plate divided by the distance between the metal plate. This means that if the area of the metal used is high and the distance between the plates are very close, we are going to have a higher capacitance. If capacitor is in parallel, it increases the capacitance, and if it is in series, it decreases the capacitance. Capacitors are used to maintain the voltage at a certain level. That is, if a voltage is fluctuating, you can use a capacitor to smooth out the voltage. We also use capacitors in converting AC to DC. When we use diode to convert AC to DC, we smooth the voltage by using a capacitor. So that is it for this video. Please like, share, comment, subscribe. Click on the notification button so that you will be notified when I drop another video. Thank you.